Okay, so let's do a quick review. Remember what we learned in last class. First is the price of risk, right? So price of risk. Anyone can recall what's the formula for price of risk?
Expected return minus the risk-free, and then divided by standard deviation somewhere.
Okay. So thank you very much. That's the price of risk. And if we have two investments, and how could we pick the investment that you think is better? Let's say we have stock A has a price of risk equals to 1.8. We have stock B has a price of risk equals to 1.5. Which one is a better investment? Ellie. Yes. So the one with higher price of risk is better one. Thank you very much. And also we learned invest in two asset portfolio. So the two asset portfolio include one risky asset and one risk-free asset. And then we focus on the portfolio's expected return, standard deviation, and variance. And the expected return is relatively straightforward. So equals to the weight on first one, the risky asset times the expected return on the risky assets plus the weight on second asset times the return on second asset. And the variance, anyone recall the variance of the two asset portfolio? Equals to weight 1 square sigma 1 square plus weight 2 square sigma 2 square plus 2 times weight 1 weight 2 sigma 1 sigma 2 times rho 1 2. Okay. We're gonna use this formula in chapter 6, this long one. But right now chapter 5, because for risk-free asset standard deviation is just equal to 0. So this one is 0, this one is 0. What is left is weight 1 square sigma 1 square. What is weight 1 here? What is weight 1 here?
Weight of our risky asset.
Yes, it's the percentage that we invest in the first asset or weight, like risky assets. What is the sigma 1 here? What is the sigma 1?
Volatility.
Yes, it's the standard deviation or volatility. And the standard deviation of the portfolio gonna equals to square root of the variance will be weight 1 times the sigma 1. Okay, so that is what we learned in last class. As I said, our class time is so limited. I wish we have a 3-hour class, so I can go slower and dig deeper. Let's look at what if we want to create a portfolio. Say the portfolio has two assets. The first asset is risky asset. Expected return is 12%. Standard deviation is 20%. Risk-free asset, the return RF is 1.5. Standard deviation is 0%. That's a feature of risk-free asset. Remember, if I buy a T-bill here today, I know the return for sure, right? No matter whether the economy in the next month is a recession or boom or normal, I know the return for sure. So that's why the standard deviation is 0%. How should we invest? We have 100,000 to invest. How could we allocate money between risky asset and risk-free asset. We have 100,000 to invest. We can allocate, let's say, 100% on T-bills, right? I can invest 100,000 in T-bills. I'm the type of person that I have very high degree of risk aversion. I do not want to take risks, especially right now. I think we do not know, there's an uncertainty in the near future, right? If Fed cut the interest, I guess we will still have some good economic conditions. If Fed keep rising interest rate, of course, it looks like no, because the Fed obviously prepare for the interest cut. Then the economic will become worse than what we see now. Or I can invest 100% in the risky asset, right? Or I can go even more crazy. I can borrow money, like short sell, like I can borrow from the bank. And then invest more than 100 in the risk asset. If I really have really good expectation for the stock market. You know, the broker will let you do the margin, so borrow money and that's more than. So how should we invest? For now, I just randomly pick a number. I invest 1,700 in risky assets. The rest is risk-free assets. Let's calculate this portfolio's expected return, variance, and standard deviation. So let me ask you the question. What is WI for W1 here? What is the weight on the first asset? If we invest 70%, like 70,000 in risky asset. No one here? Okay, good.
0.7.
Yeah, 70%. Then what is the weight on risk-free asset? 30%, right? So that's how we calculate the weight on the risky assets and the weight on the risk-free asset. And the expected return will be 70% times the risky assets expected return plus 30%, that's the weight on risk-free assets times 1.5%. So end up is 8.85%. So that is the expected return for this portfolio. The variance will be 70% squared. That is 0.49, right? 0.7 multiplied with 0.7, that's 0.49 times 0.004. So it's 0.00196. And then portfolio's standard deviation will be 70% times 20% is 14%. So this is how we calculate the portfolio here. So see, we just build a portfolio and we can find out its expected return, variance, and the standard deviation. Okay, if you have no question here, let's see what if we have a 50-50 portfolio. 50-50 portfolio is that we invest 50,000 in risky asset, 50,000 in risk-free asset. So I'm gonna randomly call some people to answer questions. So, just to try to know you better. Price, Baranowski.
Baranowski.
Okay, Baranowski, thank you very much. So what is the weight for the risky asset here?
2%.
Yes, thank you very much. So Chase.
Yeah.
What's the weight on the risk-free asset? Okay, thank you very much. Okay, so then you're good to go. Anyone want to do the calculation on the board? No? Oh, okay, then I will randomly call someone. For this one, I will give you a bonus, okay, if you correctly figure out. Ryan Bray. Who is, okay, come here, write down your formula. No, it's good. I can remember your name, and in the hallway, I will greeting to you.
I have no idea.
So
I have no idea.
give a try. So all the numbers is here, and or if you look at here, it also works.
Okay.
And remember, it's 50-50, so the weight is 50% to 50%.
Okay, let's do like, let's and then. 22 to 20. 25. I was trying to do. H part. Okay. Is this 0.12 times 0.2?
Point, weight is 50, so weight is 50.
Yeah.
This is 12% instead, so it's 0.5 times 12%.
Yeah.
And plus.
Yeah, plus 0.5. Oh, 1.5.
Okay, so write this active class.
Oh.
Need to clear. Okay, I'm gonna give you a calculator. Please do the calculation. Okay. Write it each step. So calculate this, then try.
Yeah.
Calculate this, and then pass it. Yes. Okay, you're good. Thank you very much.
Sure. Do my best.
Okay, thank you. Okay, do you all get the same answer? Yeah? So let's calculate the volatility of this 50-50% portfolio. Anyone still want to do it on the board? Yes, you can copy your solution here if you have finished it. So let me know what's your name. Yeah, I mean, I definitely give you some, like, of course, this time I will just make it clear. I will give you 1 point on the participation, including your, I will get it. Can you let me know your name? Alyssa. Alyssa. Oh, it's over here. That's good. Thank you. It's a really beautiful name. Thank you. Do me to put it? Yeah, yeah. Okay, thank you very much. So it's 10%, so it's 50% Uh, What's the variance of this portfolio? Variance, it's what's the variance? I'm gonna start calling names. If you do not know, just say pass. Oh, we have a problem. Okay. Can write down the variance here. First question. You can write here or here. Oh, yeah, there's markers. Variance,
0.5 squared.
yes.
It's 0.2 squared, right?
Yeah.
That would. You just bring on. That.
It's multiple.
Oh,
Yes.
Whoopsies.
I can double check. You will definitely get it.
As a percent.
Yes, yeah, it's a 0.01. What's your name?
Kate.
Okay, thank you very much. So the variance is 0.01. Do you all get the same answer? Okay, good to go. So we're gonna find that any dot on this line is a two asset portfolio. We can use two assets. Remember the two assets? The two asset is that the first one is a risky asset, expected return is 12%, standard deviation is 20%, risk-free asset return is 1.5. We can use only two assets to form unlimited number of portfolios. It's unlimited numbers. So any dot on this line is one portfolio, but we allocate a different amount on risky assets and risk-free assets. And here, see, the volatility is 0% and the return is 1.5. That means we allocate all our money on risk-free asset. We only hold the risk-free asset, okay? Here it's 100% on risky asset. We invest 100,000 US dollar on the risky asset. Do not invest in T-bills. So we found that the expected return is 12% and volatility is 20%. And any dot that is higher than that dot on the line means that we borrow at risk-free asset and buy more than 100% risky assets. So the weight on risky assets gonna be higher than 100%. Weight on risk-free asset is negative. So this is what we see here. And also remember we have two portfolios we calculated. The first one is this 70%, 30%. So the expected return is around 8.8. It's over here, around 8.8, and the portfolio standard deviation is 14%. So this is a 70-30 portfolio. And the 50-50 portfolio standard deviation is 10%, and the return is, as you can see, 6.75%. This is 50-50. So basically, you can see we have so many portfolios. The question is, how could we decide? How could we decide? Like, we have so many portfolios. So how much money we should invest in risky assets and how much we should invest in risk-free assets? I'm gonna give you a little time that you decide. And then I will collect your answer collect everybody's answer. Okay, I'm gonna give you a little time. Please discuss with your classmates. How could we decide that? Like what percentage we could allocate to the risky assets? What percentage we could allocate to the risk?
Like state there's a one line is different. There's one order. Others may drop out. One user when you can fit with those. It's fine. It's like so. But we one. You're one. Thank you. Since it's my own problem. They take it to 30%. Which I just saw it in the Mars. Crisis that say it's not what that I have been running. Because last it's yeah. Again, I think comes to.
Okay, so let's start from this side. What's your opinion? Like how?
I wasn't to it. I'm sorry. I'm still working.
On the math, okay. Like what's your thought? Like if you were the investor, how do you allocate your 50-50, 50-50?
Or like 60-40 risk free player. And then expect just certain like risk free, but still like, take a chance, I guess.
So, okay, 60 on risky asset, 40 on risk-free asset.
60% for risk free.
Risk-free, oh, you're more risk-averse, right?
Like depends on where you are in life, for people who are younger, a little more.
Okay. Okay.
Yeah, same thing.
Okay, so we have the first factor here, depends on our age. Like if you are younger, you are more risky taker, and if you're older, you want to save assets, right? So younger age, at the younger age, you're more risk, less risk averse and more risk seeking. And if you're at an older age, you are more risk averse. Okay.
Do you mean with at the airline, like with free, do you mean bond, or what do you mean with free?
Not all bond, only short-term treasury bond is risk-free asset. And the corporate bond and the long-term treasury bond it actually has risk. Yeah. So what's your thought, this lady?
I was situation to use
As opinions, because we are so young, we can stay as long in the asset market, and that's why I choose divided wide gap.
Yeah, that makes sense. So
Like a 61 square, I go 60 on risk free asset and 1 skills.
okay, so you two agree with each other, right? The same. Okay. Benson?
we kind of a little bit more 60-40.
60-40?
Yeah, more risky.
More risky, so yeah, risky asset, 40 on. So you all agree, or agree, each.
I'll say it's 7 years here.
So 70 on risky assets and 30, so you are more, you are the more least risk averse side. among your customers, right now, right? Right, maybe we put more. What's wrong? Yes. First. Source or not, so we call it a risk preference. Like, of course, the age is one factor to determine your risk preference, right? Okay, so let's quickly, that really makes sense. For risk, of course, we will allocate more on risk, otherwise we will have on risk. Okay, the gentleman.
I think more risk.
More risk.
Yeah. More risk.
All you agree?
8-1.
Okay, this is.
8-1 big risk. More risk. More.
Yeah, so you're the least risk averse.
Yeah.
You're a benefit.
I can go to 8.
8-20.
60-40.
That's it.
I agree with the 80-20 risk.
Is it maybe?
I'd probably go like 70-30.
70-30?
Yes, it's
70-30? 70-30?
60-40.
60-40?
Probably 60-40. 70-30.
Okay. And I think that you can see that even in our class, like we have around 40 people, right? But everyone chooses different allocation percentage. This is all determined by the degree of risk aversion. It matters how much you hate risk. If someone is more risk averse, means that you kind of do not like risk more, and you want to allocate more in risk-free assets and invest less in risky assets. Someone who is less risk averse, like the 80-20 guy and the 70-30 gentleman here, it means that they have less degree that dislike risk, so they will invest more in risky assets. Okay. So this is a concept, and the investor should pick a portfolio that respects their degree of risk averse. Like if someone who really risk averse, they can invest 100 in risk-free assets. Otherwise, they can allocate some on risky assets, some on risk-free assets. If some guy is really risk-seeking, they can borrow money and invest more than 100, like more than what he or she have in risky assets. Okay. So the price of risk of a portfolio equals to the portfolio's expected return minus risk-free rate divided by the portfolio's variance. It should equals to the degree of risk aversion for the portfolio holder, like the investor. And we can extend the numerator equals to weight of risky assets times expected return on risky assets plus weight on risk-free assets times expected return on risk-free assets. So that is the expected return on portfolio, right? So look at the formula here. It matches here, and then minus risk-free rate. Then we're gonna divide. So the numerator, the denominator is over here, variance of the portfolio. So it's weight risky square times standard deviation risky square. What we're gonna do is that we're gonna get rid of weight risk-free in the numerator. Okay, because we know that this is a complete portfolio. Do you still remember the definition of complete portfolio? What is complete portfolio?
Means you invest 100% of what you have.
Yes, thank you very much. So the weight of risk-free asset equals to 1 minus risky asset. And of course, the expected return of risk-free asset, we know it for sure, it's RF here. So we will replace it like this. And then 1 times risk-free asset return is equals to RF, so this will cancel. The only thing left. So we can write this second term as RF minus weight risky times RF, then minus RF, that's the third term. This will cancel. What is left is weight risky times expected return of risky, minus weight risky times risk-free rate. We can collect a common term, so we have weight risky times expected return of risky assets minus risk-free asset. And weight risky can be canceled with the weight risky in the denominator. So what we get is here. The degree of risk aversion for any investor equals to expected return of risky assets minus risk-free asset. How do we call the numerator here? What is the name of this numerator?
Risk premium.
Yes, it's a risky assets risk premium, right? So thank you very much. I'm gonna write down here. This is the risk premium of risky asset. And divided by weight of risky asset times variance of risky asset. So that is how we found out the degree of risk aversion based on how investors allocate their portfolio. Like if you give me 70-30, I can calculate your degree of risk aversion. 80-20, I can also calculate it. So any questions? No. So investors has a required price of risk. For a certain level of risk, each investor will require a potential reward. Otherwise, why would we invest? We bear the risk, we want return. The required price of risk equals to the degree of risk aversion for the investor. How to pick the right proportions? So it will be the formula we get here. It's a risk premium of risky asset in the portfolio times weight on risky portfolio times divided by weight of a risky portfolio times variance of risky portfolio. Or we can switch the position of A and the degree of risk aversion and weight risk asset. If we know the degree of risk aversion for the portfolio, for the investor, we know the allocation. It will be the risk premium of risky asset in the portfolio divided by variance of risky portfolio times the degree of the risk aversion for that invest. So now we have two formulas. The first formula is that if we know the allocation of the investor, we know the degree of risk aversion for that investor. Or if we know degree of risk aversion for the investor, we know the allocation of the investor. Any questions? Good to go. 1 second. So suppose your degree of risk aversion is 3.5. Usually, if you see a financial advisor and the financial advisor will give you a survey or a form that you feel like whenever you visit your physician, they will give a form that you fill in what do you experience. Like the financial advisor do the same, and they do an evaluation. And after the evaluation, they know your degree of risk aversion. Of course, I'm not a financial planning person, so I cannot skip the evaluation part. Just directly give you the degree of risk aversion here. What weight should you put in the risky asset? So the formula is what we get here because the degree of risk aversion is no. And we can easily calculate the weight on risky asset equals to the expected return on risky asset, which is 12%, minus risk-free rate. So the numerator is 10.5%, right? 12 minus 1.5, that is 10.5. Then divide by the standard deviation 20% square, which is 0.04, multiply with 3.5. So it's 10.5% divided by 0.04 times 3.5. So what I get is 75%. And then it means we're gonna allocate 70%, 75%, which is 75,000 on risky assets. The rest will be risk-free assets. So if you use your financial calculator to do the formulas, it will be 10.5% divided by 0.04 times 3.5, right? So it will be 0.105 divided by 0.04 multiplied with 3.5. Do the denominator first. So just worried that when you do the calculations, you get a wrong number, but the correct formula. So it will be 0.105 divided by, I use the brackets, 0.04 times 3.5 left brackets, so it's 0.75. Use the brackets. Remember the order of operation. So we have 75 for 25 portfolio and calculate the expected return of the portfolio. I'm gonna give you some time. So remember what's the weight. Expected return for risky assets is 12%. Risk-free rate is 1.5. So I'm gonna give you a little time to do the portfolio expected rate. Wait, please.
The 75 with the risky asset, the 25 is with risk free. Okay.
我看过那个门对，就是我们这个人为那种的the number we get here is always risk at so if we use that formula, the number you get is risk at if you use the report on that, if you use A in the formula, then the way you get is perfect. Have to go down, that will be good. I can erase. The variance, not variance, the what? I try to exploit it value. Thank you. So.
Oh, I think I've seen it before.
I was in your class last semester for the first time, but
Okay, 3, 4, 4.
Yeah.
Yeah. Okay, so that's the expected return. The volatility is here, it's 3, 4, it's 75% times 20%. Variance will be square of 15% is 0.0225. So just to give, it's just what you get, the volatility, just take a square. Any question? No question? So if we look at here, we have a red dot that is Linda's portfolio. That's the 75-25 one because the expected return, the standard deviation is 15%. Expected return is 9.375. And the max is his portfolio is here with a volatility of 20% and 12%. Whose degree of risk aversion is higher? Okay, the question is, whose degree of risk aversion is higher? How many of you guys think Linda's degree of risk aversion is higher? How many of you guys think Max's degree of risk aversion is higher? No one? Okay, that's good. So Linda's degree of risk aversion is higher. When the dot moves to this side, like left-hand side, with lower expected return and standard deviation means the investor has high degree of risk aversion, they take risk. And as the dot moves in the upper right upper side, it means the investor has low risk aversion. Okay. What is the A here? Like what's the degree of risk aversion for an investor that hold 100% in risk-free asset? So let's do the calculation. A equals to expected return on risky assets minus risk-free asset. So it's 10.5%. Divided by 20% squared times the weight on risky assets. If an investor only hold risk-free assets, the weight on risky assets equals to the investor only hold risk-free assets. What is the weight for risky asset? It's 0, right? So it's 0. And it's 0. Any number divided by 0, that is infinity, right? So the degree of risk aversion for the investor who only hold the T-bills means the degree of risk aversion for the investor is positive infinity. Just remember the conclusion, okay? I'm the person who has positive infinity degree of risk aversion now. I do not hold any stock. I just sell it at the beginning of the year and just hold the T-bills in the city. Of course, my return is really, really low. You can think about it. Right now it's around probably 4%. Any other question? So what is the A here? Look at the feature, the weight. Not the weight. With the portfolio here, the volatility of the portfolio is 25%, right? So the volatility is I think I erase it. The volatility of the portfolio equals to weight 1 times sigma 1. In our problem, what is the sigma 1? The risky assets standard deviation. What is that? The number. Do you still remember? 20%? Yes, it's 20%. So the weight of risky assets for this very risky seeking investor times 20% equals to 25%. Can you solve the weight for the risky assets? Danny Hopper?
125%.
Yeah. I think your name is Mitch, right?
Yep.
Okay, so who is Danny Hopper? Okay, can you, I'm gonna give you a chance. Can you find out the degree of risk aversion for this investor? That's a tough one. Oh my God, you missed the easy step. Okay, you can work on it. I will give you a little time, but let me know the degree of risk aversion for this investor. Quickly, no formulas, so I will put the formula here. Are you in the basement wall? Yeah, oh yeah, baseball. I don't, a baseball team. Yes, okay. So I think I'm gonna write down the formula here. Degree of risk aversion is expected return on risky asset minus risk-free rate divided by risky is a baseball win the national championship. Okay. Okay, work on the degree of risk. I know you are.
Okay. What do you want to do with it? Over my love, so yes. Yeah. Or- What do you think? Not going for that. From all the W with, oh, yes. Yeah, it's not always clear, so.
Okay.
I.
Yeah. It's just, okay, sure.
It's really installed. That's smart. Funny.
Okay, well, then you write down the formula on the board. I just quickly explain why I call it. I mean, I know everybody hates, calling it, so I give you bonus. So hopefully this help you to, feel better. The reason is I do receive some evaluation from previous semester that only a few students answer or participate in the class. So I'm like, okay, I will give you more opportunities, but I know usually you hate calling names. So, to help you, compensate your mental loss, I give you bonus, okay? Yeah, 2.1 as your classmate. Right down here, the answer is 2.1. Okay, thank you very much. Okay, so how many of you guys get this 2.1? And okay, so next one, if your degree of risk aversion is 1.9, what will be the weight on risky asset? Should I call another name? Because I'm not a native speaker, if your name is very concise, you will be called more frequently. And if especially your last name is very, very long, I may just call your first name, okay? Connor Sanger. Okay, so, do you want to do it on the board? For this practice?
Sure, I'll try.
Okay, thank you for giving a try. So you can do either that way or I can erase here. Okay, that's also good.
I'm sorry. Oh. This one can't be.
Let me double. That's point we have this practice. Yeah, it's 138%. How many you get the? Yes, okay, thank you very much. So it means that the investor is so risky seeking and the investor invested more than 100 of their capital in risky assets, okay? And of course, oh my God, why PowerPoint is doing this? So, sometimes when I copy PowerPoint from my desktop to the desktop here, You just mess up a little. So the risky assets is 138,160 US dollar, and the risk-free asset, if you look at it, is actually negative amount. And the negative means that we borrow at risk-free rate, okay? So the weight on risk-free equals to 1 minus 138.16%. It equals to negative 38.16%. Any question? No? Okay, so, what's your degree of risk aversion if you invest all your capital in a risky asset? Means that the weight on risky assets is 100%. Can you do a quick calculation? Yeah. Always remember add the percentages when you use formulas, okay? Yeah, okay. Take your time.
Is that slide supposed to be like?
In between, like, here, you just add
Oh, just.
one more, yeah.
Oh.
Yeah. Because previously I do not have this one, but I just want to add one more. Yeah, I previously just write it down this one on the previous slides by hand, but then I said, why bother? Yeah.
Okay.
That looks good. How about look at that? Yes, that's spheres. Pointed for sphere, yeah. Then times one. So not the on the power. It's the whole thing.
Okay.
Yeah. What do you mean? Yes. Yeah. So it's 2.625, do you get the same? Yeah. Okay. So how we determine the risk averse? Basically, I think we talk about the two factors here. We all covered it. So the first one is age, right? Like whether you are at a younger age or your later years, and then your risk preference, right? Like what you are more risk averse the person or not. So that's basically all for chapter 5. We do have some pieces here. let's look at this. So determine whether investments are acceptable or not. So an investor has a degree of risk aversion of 3.1. And if an investment has a price of risk that is higher or equal to 3.1, then the repaired price of risk for the investor will invest in. Otherwise, the investor will not invest in. Do I make it here clear enough? So if the price of risk generated by the asset is higher than the degree of risk aversion for the investor will invest in. Otherwise, investor will not accept. So for asset one, asset A, the price of risk is 7% minus risk-free rate 1% divided by 10% squared. 10% squared is 0.01. So it's 6% divided by 0.01. That's 6. 6 is higher than the degree of proportion for the investor. Investor will invest in. I'm gonna give you some time to calculate the price risk for B and C and whether investor will invest in or not. So the investment criteria is here. Price of risk generated by the asset is greater than repaired price of risk, which is the degree of risk aversion for the investor. Otherwise, we'll reject the investment. So this will follow the criteria and make the deal. We want to write on the board or. Yeah, okay, that's good. Thank you. Go.
Over this one.
Oh, nothing. Yeah, you can write. Okay, thank you. Let me know your name. Okay, it's a very concise. Thank you. So, do you all get the same answer? Any questions? So a client comes to you, the current capital allocation is 80% in risky, 20 in risk-free, and the condition of the market. So I just want to let you know, this M here represents the portfolio, is a market portfolio, which include all assets on the market. Usually we use S&P 500 to represent market portfolio. The simplified version of market portfolio is S&P 500 index. So usually for two asset portfolio, the risky asset is the market portfolio. Okay, so if we said we invest in a two asset portfolio, one is risky, another is risk-free assets. The risky asset will be market. And can you find out the degree of risk aversion for the client? Really? Or there's no record. Just that.
I think that was there.
Okay. Yeah, because I previously have a friend, his name is Alexander, and
Oh, sure.
he goes short with Xander.
Mhm.
From what I will, you read with video some, I see. So, yeah. Thank you very much.
Thank you. Okay.
Okay, so we're gonna finish. So that's his 4.5. 4.25. Do you get the same answer? I think I'm gonna stop at here. Of course, I wish we can do one more practice, but I think we kind of run out of time. Okay. If you have any question, feel free to say. Question. Have a great one, and see you next week. Oh.